Okay, mic check. Yeah, it's working. Looks like it. Okay. Go. Oh man, it's fighting with the. Move these up a little bit. Maybe these will be better. Okay. And how do I share this? Okay. Let's get started here. Make sure my audio. Yep, audio looks like it's going. Okay. So if you noticed, this time I'm a little better set up. So I do have a camera that's just dedicated to just looking at the daisy here so you can see what's going on. So where we left off last time is I believe we uploaded a program that, and we just changed the color value. So this basically these two knobs are adjusting the red and green, blue and green. Let's see. Maybe it was in Daisy examples. Did I make some changes? I did. Simple LED. Let's get Vim going. And so if I remember correctly, I believe that originally, so this is red and blue. So knob 1 we see here, so this is knob 1. And then this is knob 2, so right, so since we took all the red out, and then there's the blue, and there's red, so we make pink. Take all the blue out, there's our red. Okay, but we wanted to prove out the pipeline of building, so let's change this back to green. Let's just say, okay, well, let's do a make, and this will build. Looks like it build, and then make, I think it was program DFU. Oh, and so I got to put this in boot mode, so we're going to hit boot and then reset. And yep, that got it. Okay, apparently this error is totally normal. But if you notice, so this came back on. So right now, yeah, so this is the red control, and then this should be the green control. Yeah, so anyways, all that was basically just to kind of prove out that, you know, we can get firmware onto our chip and that everything is working. And so pretty happy with that. So now we're going to make it make sound. So if you notice here, now, and this might be tricky and you might get to watch me beat my head against the wall. So this is the line out of the pod, and this is going over to a mixer off screen that way. It's also, I don't know, there's a lot of things going through that mixer right now, including my microphone. So I don't know, we'll see how that goes, because but basically our objective today is to get sound out of this guy. And so we're gonna do the oscillator example. So let's see, or we had a looper. Oh, one moment. Okay, so yeah, let's go into the simple oscillator and see if we can get this guy going. Is this where my Vim is? Nope. Okay. Okay. Reading through the code a little bit, so it looks like cool. Oh, these are neat. So, okay, apparently the class that comes with Daisy has a couple different waves defined that we can use. So, what is waveforms? Okay, that's fine. Okay. Maybe somebody else defines waveforms. Or no, that's what we're doing here. We're defining waveforms. I'm still struggling with the C syntax. I should probably read up some more on it. But I think that what's happening here is this is a struct, right? I think that's what and basically each one of these is going to be a uint8, unsigned integer, 8-bit. Don't know what the T stands for. Anyways, not get bogged down on what we don't know, but try to have a framework for understanding what we do know. And so this is just accessing static properties on an oscillator class, which I'm assuming is coming from one of these. Not sure which at this point. Figure that out more later. Okay. So this we kind of covered a little bit last week, but this is just a utility class that helps for interacting with. So this is going to have the helper classes for like the buttons, the LED, the knobs, the encoder, the output, which I think is going to be very relevant. Pod. So and then there's the oscillator, and then parameter, which I'm interested to see what is a parameter. Is it just kind of like this abstract thing that you can hook up to any sort of control voltage, or I don't know. Let's see. So audio callback, we saw this before. This gets evaluated every tick, which we love, or I love. Right, and so we're not doing anything in the while loop. And I have a feeling that this is one of those classic things that you're supposed to know as an embedded programmer that I don't know, and why I'm here to learn it. I have a feeling this operates from an interrupt. So this is an audio, like underneath the hood, that there's an interrupt happening that this gets evaluated. It's some sort of interrupt interval, or there's an interval that like basically claims time on the CPU to run this. And so I think that that's just a cleaner way of doing it than the while one. I don't know precisely why. If I had to have a guess, this probably is a little more brute force-ish, you know, where you could have something that kind of runs away and locks up the CPU inside of the while, whereas the interrupt operates, you know, in a more controlled environment, so you can kill an interrupt if it misbehaves or something like that. That's just a guess. I'm just kind of talking out loud of what goes through my head. Debounce control. So this is debouncing is a technique where you don't want to let something evaluate too many times, and so I have a feeling that's with the controls. Like it doesn't. You don't want to spend too much. You want to read the values that are coming off the controls as quickly as possible, but obviously you don't want to do that so fast that you can't produce audio. So waveform, here we go. Hardware encoder increment. So hardware is coming. So this is coming up. So this is this guy, the encoder. Increment. You know what? As I'm reading through this code, I'm sure that's wonderful, but we should probably start with the README. Let's go look at this somewhere real. examples. Okay. So the encoder controls the waveform? I was led to believe. So, okay, audio out. This makes sense. Octave up, octave down. Okay, so the buttons do stuff. And these just the frequency. Interesting. Okay, cool. Okay, so so now that we kind of have a framework for what we might see in here, we know that hardware.encoder.increment. So this is this reading it, or I don't. Okay, we'll come back to this waveform. DSY clamp. That's got to be somebody else to find that. So does this work? No. I wish I could have a go-to value, but I still haven't gotten my you complete me working with flags. We'll come back to that later. Waveform. Okay, so maybe I would expect this to just be a read value, like it's reading what the value of the waveform is. And then this, yeah, so clamp, this is a utility function that is going to clamp. Like, so basically if you go into a negative value with the encoder, it's never gonna, it's just, you just, or this clamps you between these two. So this is like doing a math.min and a math.max. So, and apparently increment, I would assume that to be an action, like it's like setting the encoder, in, you know, like increasing the encoder, but I don't think that, I guess this is just how it reads it. Maybe, I don't know, because this is a, so this goes to the next one, and do we want that happening every tick? I don't think we do, because this is just always going to, the way that I read this is that this is going to increment all the way to the last waveform, which is poly bleep square. And I wouldn't think that you'd want that, right? You'd want to just read this. So I don't know. We'll have to come back and understand this later. Okay, so whenever we press on key down, octave plus plus, cool. What is octave? Octave is an integer, okay. So that's, so button 1 is octave down, and then button 2 octave up, as we saw earlier. So we clamp, so we don't can't get out or under audio range. Cool. MIDI. Ooh. What? It's a parameter. Okay. Convert MIDI to frequency and multiply by octave size. This is interesting. So here's our parameter. And then empty off, this has got to be a utility function coming from somewhere. We'll look at the definition of it later. This interesting. Yeah, but this is how the frequency gets set. Audio loop. So this is our buffer size. We don't set the buffer size anywhere, or at least no static variable. But I love that sig, just the signal. And then we have our outputs. Right. Okay. So the outputs come from they get passed into the audio callback. So I'm guessing this is the left and right channel. So as part of me start doing some clever stuff, like, right, like applying an LFO to the frequency, and then, you know, have it be, and then applying that and then having that second frequency be on the right output. So then you get a stereo spread, right, with like two different subtle frequency. You'd obviously want to clamp that pretty close, you know, to what the original frequency was. So we only have one oscillator defined. So it's like, if I wanted to be clever and do something like that, I'd have to set a second oscillator. And we'll do that later. Let's just see if this works first. Let's just see if this works. Okay. So a net synth, right. So where's our sample rate? Just wherever the hell you want it to be. Okay, whatever. Or whatever. No, come on. Thank you. So this is going to be, yeah, okay. Okay, here we go. So this is interesting. What I was curious about before was that parameter, which is P frequency. So this gets initialized here. Hardware, okay, so it starts off at whatever this guy is. Interesting. Using MIDI note numbers, yeah. Huh. It's interesting that MIDI's involved in the mix here, but set amplitude. 1F. What? What is that? What is I mean, it's obviously like a number, right? So this would be, if F, I guess, makes me think hexadecimal. One. I don't think. So, and I also wonder. Okay, so, and maybe, but hexadecimal numbers. Yeah, so this is X, so that's not how you define that. Let's see. So, well, let's try. Instead of attacking it that way, this signature will obviously define what it wants as an input. So let's see if we can find that. Hang on. Yeah, let's back out some. Yeah. So I just did a grep here, and I'm just looking through, trying to figure out. Trying to find where set amp is defined. Not doing the greatest job. And I bet you this is because my grep didn't go into... So what? .f. Okay, so it's a float. Tells the compiler is a type float. Okay, so this is just a fancy way of, even though you passed it an integer, it wants to, you're telling the compiler treat this as a floating number. Cool. So if I had to guess, and that's because we're passing it, so this is, we want the amplitude to be as loud as it possibly can be, which is 1, and that's an integer. But if I had to guess, the amplitude is actually from 0 to 1, and so normally this number would be, I mean, they could have just done that, maybe, I don't know. Let's not mess with this. Okay, feel like I have a pretty good understanding of the code here. Actually, you know, for the amount that this code does for on this hardware, only having this amount of code is super impressive. Like, I have a feeling like the Daisy guys and the Daisy community really have knocked it out of the park with their utility libraries here, because knowing what I know about hardware programming, there should be a lot more like there's a lot of details here abstracted away that you don't have to deal with it, that deal with the like the GPIO and deal more with you know, the ADCs and things like that. And I think that they've done a really fantastic job of abstracting those away for if you are probably at the level of a programmer that I'm at, you can make audio like pretty good audio applications like with this framework. But I think that it's still, you know, it's not quite like you know, one of those visual like Macs. You know, it's still it's a layer below that, I would say, or many layers. I'm not sure how many layers. I'm trying to figure out all the layers. And this isn't all the way down, right? Because we'd be having to write specific code for the STM32 chip on here, and we're not having to do that. We're just kind of dealing in the Daisy space. Not only that, like the initialization for like the, I'm not sure, I guess this would be a daughter board. I'm actually not sure if that is a daughter board. I was just introduced to that term. Maybe I don't fully understand what it means. Anyways, here we go. Finally, the moment you've all been waiting for. Let's put this on the board. Oh, simple loss layer. Okay. Make. I kind of want to read this. Cortex-M. STM32H7, so there, yeah. So this is ARM, GCC. This is some sort of specific compiler for GCC and ARM. I have no idea what EABI and none are. But I would imagine that what this guy loads up preloads a lot of the libraries that the STM32 stuff is going to need. And this is where we're saying, hey, we're using an STM32H7. So load up those libs for us. So that's pretty nice, because otherwise you're having to grab like a specific compiler from, maybe, I don't know, maybe not. Okay, and these, I feel like these are like paths, right, for like where to look to resolve, like include and such statements. So, okay. Some sort an output. So there's stuff going into /build. Let's take a look at build. Yeah, okay, so, and then, okay, and I can't really view the make file because I believe it's like taking, I don't know, maybe I don't want to get too off the weeds into that right now, but I have a feeling that all these get written like this, like goes into the like the bootloader or something like that, and just, or maybe not, or you know, but these are very low level libs that need to get flashed along with, you know, and this gets flashed into probably a space in memory that's reserved just for running programs. If I had to guess, it was the hex that probably gets flashed there, but who knows, it could be the binary. I'm not sure. Anyways, program DFU. Right, got to put in boot mode. Boom, boot mode. I just love that I don't have to swap the camera. You can just see it. I did it. It's down here. So I wonder if like there's like a further build process. So all these get written out, and then there's might be something at the end here that kind of bubbles all those guys up. Yeah. Yeah. Okay, here we go. So it looks like these statements compile. So the first two are compiling some system level libraries. Then this third one here, fourth one, is compiling our program. And then this one is also compiling our program. I don't know the difference. You know what's interesting is these are GCCs and then these are G++. I don't know the difference. Okay. Interesting thing to notice. Anyway, so then we have our programs. And then it looks like object copy. And so this is going, I think that this is turning this hex into a bin, yeah. Or there's something, so we combine, the G++ makes us an L file, and then from that L file we can make a hex or a binary. And if I had to guess, it looks like this guy, we're using the binary, but I don't know what context we'd use a hex. So that's interesting. It's good stuff to know. Good stuff to know. Cool. Okay. So now that, and I know you can't see it, but I just realized that, oh right, this guy automatically restarts. We should be hearing something right now. And I look over to my mixer, and there is just maybe y'all can hear it? Oh, you totally can't hear it. But I can. I have it muted. Hold on. Okay, sorry. I just realized that as soon as I flash it, and then I talked a whole bunch, you probably couldn't hear it because there was an oscillator, but I didn't have it turned on the speakers and in here, so so you were hearing something that I couldn't. Okay. Okay, yeah, so you might have been able to have heard me, but man, that is loud. So we're gonna get that to a more reasonable spot. Now I can hear, I hear myself, and I can hear, but, you know, we don't want feedback, so I can't put it through my speakers. Okay. So cool, it works. I shouldn't be surprised, but I totally am. Okay, and so if the instructions were to lead me to believe anything, it would be that this button does something. What does it do? It goes up an octave? Oh my god. And then this is a frequency. Goes off the bottom there. All right, little oscillator. So this guy's gonna change the waveforms? Yep. Sounds like a square wave. let's go back. What? Okay. That's not what I want to look at. I want to look at this. So what were sine, trie, sol square. Okay, that sounds right. So sine, trie, sol square. There's like an extra one. So 1, 2, 3. Sorry. 1, 2, 3, 4. And there's another one. And so this is gonna, and that's, I feel like that's a bug. That has to probably do with the clamp. Going, like, once you go above. Oh, it's weird. Why is it has 5, right? Okay. So let's make a looper. How am I going to make a looper? It's hard to tell if you hear some noise there on the left channel. And I think that probably has to do with the cable that I'm using and the harness. This is not the greatest setup, but whatever, it works. Okay. So what's next? I'm actually gonna such interesting sounds to me. So let's head back over to the looper, because for my purposes I am way more interested in looping stuff. Not what I wanted. That's right, I don't like reading that. So we're gonna come back over here. So simple oscillator, you served us well, thank you. Play, pause, record. Modes. Okay. So what would be a good way to get audio into this thing? Because surprisingly, I don't know. Running a cable from my mixer, I don't have a great setup for that at the moment. I do have some Volcas. Hold on. Boom, battery powered for the win. You can see, hopefully, see the Volca FM here. So we're going to plug this guy into line in. Let's get the headphones up. Let's get a better one. EPM. My favorite. Okay, sorry. So, alright, headphones. Let's put the volume to about the middle there. Okay, looper. Right, what is this? Button 1, play pause. Record, hold to clear. Okay, so this guy. Knob 1 looks like live loop mix. So let's stick that right in the. You know what? I'm just gonna go ahead and put you in bootloader mode, so that way you're quiet. Okay, audio in, audio out. Perfect, perfect. Red indicates recording, green indicates playback. Okay, so without diving into this code, let's see if this works. Do a build. I heard the audio pop. Okay. I'm not sure. So we programmed it. Cool. So what? So if we hit. Okay, so it's like. Okay. So it's recording. So record to enable. So if I turn that off. Okay. That doesn't seem right, right? So it's okay. Button 1, play, pause, record, enable, hold to clear. So make a noise, or you know what? Let's just. Okay, there we go. Got a sequence playing. No output. Okay. Cool. So it didn't work, right? Maybe. Let's see. Nope. Okay, none of these work. And we heard the pop of the audio, so we know that. And it's in line in, and that's in line out. Okay, so something's up. Debug time. Here's my looper. Alright, this is. We kind of went over this last week, so I'm not going to do a deep dive of this. Too much. Right, so this is where I want a remote debugger. Because how do you console log and be like, oh, well, what's record, right? Why is this not? Okay. Oh, maybe there's another one. Because I'm interested in so we can get audio out, but can we get audio in? Is the question. What is multi-effect? Oh, let's try this one. Multi-effect, make. Oh, and then go into bootloader mode. Program. Okay. This guy's obviously doing something. I wonder if the volume's just not enough. Let's read the multi-effects. Let's see. Red, green, purple. Where are the modes? Okay. Reverb, delay, bit crush. So something is up with, it's either not getting audio in or, you know what? I remember that. I think this cable's bad. Let me find a different cable. So it's obviously working. You can hear the good stuff. Oh, God, I don't have many. I wonder if that line in is stereo. It's gotta be, right? Aha! Oh, no. Well, maybe it's about to be mono. Okay. There we go. So this is just a modular patch cable. Okay. So this is dry wet. Okay. This is cool. Let me turn the volume up. All right, what about delay? Bit crusher. My buddy Greg's favoriteest thing in the whole wide world. Okay. Let's go read the code for this. Aha! Yay! Okay. So these delay lines are super interesting to me. And I want to learn more about them. Right. So they did stereo spread. Oh my god. Have you ever seen the tabs versus spaces episode of Silicon Valley? Spaces. Okay. Come back to that. Anyways, so what's going on here? Right, okay, so here's our switch based on the encoder. Cool, so are these just running all the time? Oh, no, because this happens on the callback. Alright. It's a phone pole. Feedback. Not sure what controls. Got it. This is just so that initializes it though. Who's setting our feedback? Should be here we go from the knobs. This code's a little clunky, but whatever, it demonstrates the point. Okay, let's see, how are we on time? 45, that's usually where I like to call it. Be nice if we could get to an hour, but I'm haven't gotten to do. Still just exploring, experimenting, figuring stuff out. I think. So let's set a goal for next. So I feel like we have a pretty good development environment for working with this now, which was kind of my goal for there. And it's nice that I also wanted to make sure that the examples with the audio buffer were working. Put it back on the reverb. Though you can definitely tell there's some USB noise that's in there. Why is the left is way louder than the right? Maybe that's because it's a mono cable. Figure that out later. Okay, anyways. Sorry, a little ADD moment for me there. So anyways, pretty happy. Ran through the examples. So I think we should build our own application for this next. So what do we want? What do we want to do? And I think, do they have filters? Chord machine. I am so much less interested in building like a MIDI sequencer, things that are sequencing related, as I am effects for this, like real-time effects. That doesn't do what I think it is. What's a music box? Ooh. Why is this one so much more complicated than the rest? Okay, let's go on an adventure here. What is music box? Trigger envelope sets a new random note. Decay time. Decay time. Okay. Let's go. What do you do? Okay. Set this guy to boot mode. Oh no, what am I? Oh, that's really bad. I need to fix that. This one of the header pins got bent there. Boot mode. Music box. Make program dash DFU. Okay. I think, yeah, so I can actually kill this. Is that just a ground loop when that's plugged in? No, okay. It's obviously a USB ground loop. So, trigger new. Oh god. One of my cables. That would not be cool. Okay. Guess so, maybe? I don't know. Or something in this harness failed, but whatever. There's a lot of reverb on that. Decay time. Okay, so this is the reverb decay. This one's reverb decay. This one is. And I'm sure that this is set to a scale. Let's see if we can find the scale. Get new note, my random value. Scale, yeah, here we go. Yep. So let's see. Second. Well, hold on. Yep. Minor second. Let's see. 4. That would be. Excuse me. Major second. 4. What would that be? So if we start on C, so that's 2, 3, 4. So it's a major third. And then 5 is a fourth. Then 7 is a major fifth. Perfect fifth, whatever. Right? C to G? Yeah. And then, oh, sorry, you can't see. I'm measuring it out on the Volca keyboard down here. So anyways, that's 7. So then there's 8, 9. So that's going to be the 6, our minor. And then 11, which is this guy, which is our 7th. So it's a major scale. It does not sound major, if you ask me. It sounds like maybe it does. I wonder what's going on in that reverb. I'm super interested in what this guy does. Right, so yeah. Anyways, I got super distracted because this thing's really freaking cool. But where do we go from here? So I actually wanted to create an effect that is based on a delay and a reverb. So there's part of me that thinks that I should make my own reverb. And so I should dig into what this guy does. It's my puppy dog asking for something. He's been fed, he's been walked. I don't know what he's asking for, but he's asking for something. Okay, we'll leave it there. Next time, yeah, let's dig into the reverb. Let's see if we can start creating our own reverb, because that's what I want to do, is eventually be able to code my own effects. So while I'm sure that this reverb that is supplied with Daisy is amazing, I want to make my own. The whole point. I want to eventually be able to break out of the Daisy space.